Hello everyone. So today in this runtime terrain generation plugin, we are going to work on LODs, all level of detail. That means now here you can see in the close range we have high detailed landscape, and in the far range we have low detailed landscape. It may not be very clear here, but if I enable the wireframe mode, now you see, let me speed up a little bit and go up. Now you see in this area or in these tiles, you see a higher poly count, and in these tiles you see a relatively lower poly count. And as I move further closer to those tiles, now you see those low poly count tiles turns into higher poly count tiles. So this is how the load system is going to work at the end of this episodes, where I am working on the LOD system for this runtime terrain generation tool. Also, along with the poly count of the landscape, you see the amount of foliage placed on those far tiles are also reduced. So that is also taken into account when we work on level of detail for the runtime terrain generation. So if I eject from the character and go to the top view in the wireframe mode, now our character is here. So now you see closer to the character we have higher poly count tiles, so high detailed tiles, and as we go further away from, now you see lower poly count landscape tiles. So this would allow us to render a large area of landscape with minimum performance impact. And if I start moving towards this low rendered areas in this lit view, you will still see the foliage is being added, and the foliage count is increases as the detail on the landscape increases. Alright, and before we get started, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel to the date from the Patreon page. Once you become a member, you can download anything without a limit, and also you will have access to my Discord server as well. Alright, now let's get back to today's tutorial. Right, let me open this Visual Studio project and then run the project. Here is our project. Now let me go to the top view and simulate. Now here you can see there is no LOD system in place yet. So because of that, you can see the poly count of all the tiles are similar. Here, let me open the world.ng header file that is actually inside this CLM world.ng plugin, because in the last episode I converted this system as a plugin right here. Here, this generate terrain function. This is the function that is responsible for generating the mesh details for each tile. If I go to the references of this function, you can see this function is called in here, in this do work function of this class, this 𝐹𝐴𝑠𝑦nc_world_generator. The reason that it is called in that way is because we are calculating mesh data asynchronously, so in a background thread, so it does not interfere or stall the main game thread. Until all the mesh data is generated, main game thread continues, and only once when the data is available, when all the calculations are complete, we do the drawing of that calculated terrain tile in the main thread, because we have to do that in the main thread, otherwise we get some errors. So if we are to implement a LOD system, I think this is the best place to start. Here I'll add additional parameter. Let's call it LOD. Better use capital for LOD. because it stands for level of detail. Now that where I have added some change here, we have to reflect this change in all the instances of this function is referenced. So that means here in this implementation, and also in the place where we call it. So for now, we don't have a way to calculate or give the LOD factor as an input. Therefore, I'll just use 1 here. Later on, we will refactor that and add the proper value. Now, let's go to this function. So here, all these calculations depends on this offset, in section x and x vertex count, y vertex count. So everything is depending on those main variables. So if I want to implement a LOD system, that would essentially change the x vertex count and y vertex count per type. Therefore, I'll add another integer variable at LOD x vertex count, and this would be equal to x vertex count, which is the vertex count if we don't have any LOD system. If I divide this by the LOD factor, we will get a reduced number of vertex count. So as this LOD factor increases, the vertex count for that LOD will decrease. Now I'll do the same thing. LOD what equals vertex count divided by LOD factor. And here, when we calculate vertex positions and UVs and everything else, I think we consider this cell size as well. But this cell size is only relevant to the original vertex count. So I'll add another variable, LOD size equals cell size. Now this time we can't divide, we have to multiply. Let me explain why. When we have the original vertex count, let's say we have 1, 2, 3, 4, something like this. Now the cell size is this distance, and when we have a higher LOD, that means a lower vertex count, let's say now we have something like this, then the cell size is this. So as you can see here, the cell size has to increase proportional to the load factor. Therefore, that's why I have multiplied it here instead of dividing. Now, in place where I have used the x vertex count, I will be using LOD x vertex count, and y vertex count will be replaced with LOD y vertex count, and cell size will be replaced with LOD cell size. When the load factor is 1, that means it would have the original number of vertices, so the base load level. So in that case, this number will be same as this number. Okay, now let me copy that, and starting from here, no, for the offset, I'm planning to keep the same overall size of the tile despite the load factor. So therefore, I don't think for the offset, I have to use this x vertex count replaced with the LOD x vertex count. So I have to keep this line same. So starting from here, I'll replace x vertex count with LOD x vertex count. We are still in the same function. make sure that you are not exceeding the bound of this function. Otherwise, the whole code can be a mess. Yeah, that's it. And replace y vertex count with LOD y vertex count. And replace cell size with LOD cell size, starting from here. 2, 3, 4. That's all. Right. Now let's go back to our project and compile once to make sure everything is working. Okay, successfully compiled. No errors. Now if I simulate, let's see. So this is the original vertex count because I am still using the load factor 1. Now let's test with the higher load factor. That means I have to change it here. So let's use something like 4. So we should be able to see a clear difference. And since it is inside the C++ part, I will have to compile again to see the difference. See, it's working, but now you see a problem. There is a gap and we need to fix it. But apart from that, the LOD system is working. The only thing is the gap. Here, if I go to the perspective mode, you see there are gaps between tiles. Alright, now let's see how we can do that. This is what happens here. So when we have the original vertex count, let's say it's like this, we have a certain width and height, or whatever the x width, y width, whatever this length. And when we are in a LOD level, when the vertex count is changed and the cell size is also changed, and here these are integers. So I think therefore this is where this issue occurs. So the total length that we get for each side is decided based on this Now the next step is, how do we dynamically change the LOD level? That means in the tiles that is closer to the player, we should have a higher poly count, and as the tiles are further away from the player, they should have a lower poly count. That means a higher LOD number. Okay, so for that, let me open the word engine blueprint, and here we call, where is it? This generate terrain async function. So into this function, we would need an additional parameter to pass the LOD level. So let's go back here. Here, I'll add another input parameter. Before that, first find our references. No references. We do have references. Well, actually, this is the implementation. No references here because we are only using it from the blueprint. Okay, so list edit level, and make sure to make that change in the implementation as well. Otherwise, this is not right. Now here, what we do is we get this intersection index in X and intersection index Y and set these variables, because these are the variables that I have used to communicate to the other thread that do the actual calculations. If I go here, you see section index X and section index Y is used here. And I have defined them as variables in the header file. So under this, I'll have another integer LOD by default. I'll leave it as 1. Now, and here, when I set visit, here, one issue. If I use the LOD level, oh, this should be simple. If I use the same name for this variable as well, I think we might have name conflicts. So I'll call this cell LOD level. Cell also means the tile that we are calculating currently. Well, here also this should be separate, okay? And cell LOD level equals the LOD level that we receive from this input. But we should not get 0 here. If we get 0, we would have a problem. Therefore, to make sure we never get 0, I'll use math in main, max 1, or what in LOD level we receive. So this will ensure the minimum value that will go into at cell LOD level would be 1. This is just an extra step to be on the safe side, to avoid any crashes. So divide by 0, things like that. Now here, instead of this hard-coded value, I'm going to use cell LOD world generate LOD level. Now compile it. Comparison successful. Here we have now LOD level. So this is the reason I made that safe step, because by default this is 0. If we put 0, the engine would crash, I think. Now here we should be able to test. If I put 1, get the original cell count, and if I put, wait, we should get a reduced polycount. Yeah, it's okay. Now we need a way to calculate the LOD level. But one more thing, we get this tile to be calculated from this 𝐂𝐡, and I think it would be a good idea if I store along with the tile coordinates the required LOD level as well, so that we can simply use that here. Because also in future we would need a system to track what is the current LOD level a certain tile is already rendered. So as the player go closer to those tiles, we need a way to update the LOD level of those tiles as well. So let's go here, and what I'm thinking of doing is, here we have the 𝐂𝐡 tiles. The data type is a T-map, and the key is f endpoint, and the value is just an integer. So this endpoint hold the XY coordinate of the tile that we want to generate, and this integer will hold the mesh section index once the tile is generated. Now, instead of this int, I'm going to convert the value also into a f endpoint. So the first value of that f endpoint, that means x value, would hold the mesh section index, and the y value would hold the LOD level. So first, let me find all the references, because we're gonna have to update all of them. Okay, I added a comment. Now, f endpoint. Now we will have a bunch of errors if I try to compile now. So before trying to compile, let's fix the issues. So now here, endpoint, not just the mesh index. Let's put load level. Also, that we already have it here. Now the key array value array will become white. Okay, replaceable node section will be coming from X. Here also in spell LOD level. Here now entry value on X. Again X, because that's the mesh section index. And here, okay, now I think we have updated all the references here. Tiles, only 2 places. Okay, we would get errors in the blueprint. Let's update them as well. Let's see if we get any errors in the C++ level. All good. And the C++ level, these are the blueprint levels errors. So here, split this and X, because X is the mesh section index here, and here we should put -1 here because that's what we were doing before. The reason that we put -1 is if the mesh section index for this Q tile for -1 is -1, that means we still haven't generated that tile. That's how I was tracking the status of the tile generation. Okay, compile, no errors, and let's play. Yeah, things are still working, nothing is broken. Now, the only thing we should do is here, now I add 0. Instead of that, I should give the LOD value that we need to generate this. In the blueprint level, I'll add a new function, yeah, LOD level for tile, but maybe not like this. Here, this is the index of the tile that we are going to enqueue to be generated. So, if we get a location, the reason that I am using this is should either return player character or player pawn or whatever the valid actor in the current session. So that's why I'm using this function. From this, I break this. This indexes represent the location of the tile divided by X is divided by X vertex count and Y is divided by Y vertex count. That's why I call them tiles indexes rather than locations. So we may have to do the same thing for the player as well, because we need to get the player's tile. So actually we already have a function to do that, but here we only get px, py, so player's x index and player's y index. But the issue here is I need float values to get accurate distances for the calculations. So x divided by, we have to use the same logic without the truncating, right? And using these two calculations, we can use the distance 2D vector. So this is distance 2D. This one, yeah, this one. Okay, so the player location is this, and the tile location, we actually get it from here, but this gives us, if you consider this as the tile, it gives us this corner, not the middle. Therefore, I may have to add 5 or to get the middle. 8, right, and it. Okay, this. Oh, we can actually, let's take it from here. Lord. Okay, Now again, I'll do that max function. So ensure again that we get 1 as the minimum load level, then put it here. Alright, so this is the calculation of load, and I can, why do I have a debug point here? I can convert this to a pure function so that we can connect this to something. Okay, LOD level, tile LOD level, and pure function. Now, first one is X, second one is direction one is LOD, and yeah, this is already connected, right? Okay, now when we generate the tile here, instead of giving this hard-coded value 3 from the queued tiles here, this Y represents the LOD level, so we can use it. Now, in order to test for higher tile count, I'll have to increase this terrain tile count. I'll use something like 8 by 8, and this tile replaceable distance, let's have it something like a higher value, this. Okay, but still this is not complete because there are some things that we need to change in the C++ level. Now that we get variable LOD levels, we can't rely on these pre-calculated subtriangles and subset vertices. Yeah, vertices is fine because vertices are calculated again and again. So we will have to get rid of this part. So let me, for now, comment it out. And then, because when we are calculating for a different LOD level, this number of triangles is different. So we need to clear or empty every time we calculate the triangles. For now. Later on, we will find a way to reuse the calculations, but for now, we can't. So, that is empty. Okay, alright. Bumper. Now, let's simulate and see. So far, same. Okay, now we get it. See, here we have low poly tiles. Okay. So the system is working. Now the next step is, this is only static for the moment. So we need a system to update the LOD levels as the character moves around the level. So we have already taken around 35 minutes. So therefore I think it would be better if I break this episode from here, and in the next time, let's work on the LOD transition. So before that, let me play one more time and see. Now you see in the distance, you already see low poly tiles. And by enable wireframe mode, you can see that in this view as well. So yeah, let's look into how to make the LOD transition work in the next episode. Thanks for watching. As always, updated project files will be available for the download in Patreon page. Link would be in the description below. Feel free to let me know what you guys think about this episode in the comments below. And don't forget to like and subscribe. See you in the next episode. Goodbye.